welcome to Clean Coder YouTube channel. If you are new to this channel, I'll highly recommend you to subscribe to my channel as I make content related to software engineering, system design, and data structures and algorithms. And now we have reached towards the last OOPS principle, which we are going to cover in this video. This video has already gone towards 40 minutes, I think, but I think this video would be really worth it if you are just revising these OOPS concepts just before an interview. So you'll be able to excel in the interview since you will have a really in-depth knowledge of the OOPS principle after completing this article. Okay, so let's try to complete this polymorphism part as well. So what does polymorphism mean? Okay, so we can dissect this word into two parts. Okay, poly means multiple. Okay, poly means multiple, and morphism means forms. Okay, forms. So what does polymorphism means? It means multiple forms. So he has written here is polymorphism is the ability of an object to take on many forms. Okay, many forms. Polymorphism in OOPS occurs when a superclass reference and a subclass object. Okay, for this you want superclass reference and a subclass object. So all Java objects are considered to be polymorphic, right? As they share more than one is a relationship. At least all objects will pass the is a test for their own type. And the class object, we know that every class in Java implicitly inherits object class, right? So this is what he is trying to mean by this. Okay, we can access an object through a reference variable. A reference variable can be of only one type, and once declared, the type of reference variable cannot be changed. Okay, a reference variable can be declared as a class or interface type. Single object can be referred to by reference variable of many different types as long as they are the same type or a super type of the object. Okay, so with this we have completed the polymorphisms definition part. Now we all know that the polymorphism is of two types, right? The first part is compile time polymorphism or method overloading. It is also called compile time polymorphism. Okay, so what does this mean? Okay, so method overloading in Java is achieved by compile time polymorphism. So if a class has multiple methods and they have the same name but different parameters, right? This is known as method overloading. Okay, so for method overloading, these rules must be followed. Only then it could be a valid overload. Okay, so they must have different parameters list. Okay, they must have different return types. Okay, and they must have different return types. Okay, may have different access modifiers. Okay, may have different access modifiers and may throw different exceptions. So these are all like different forms of providing valid overloads for a function. Okay, so let's try to scroll down a bit. So in this example, he has provided us this code method. Okay, and this code method doesn't have any argument, and the second override which he has provided has a string argument, right? So these are two valid overrides, and here in this example he has demonstrated that when he is calling without any parameters, the first one is getting executed, and with parameters, second one is getting executed. Okay, so in the note he has added that static methods can be overloaded as well. Okay, so you can overload static methods as well. Okay, so now let's move forward. So here he has just demonstrated that he has taken a static method add and he has provided an overload with 3 arguments. The original one had only 2, and he has proved that his override is working fine by providing 2 and 3 arguments. Okay, now let's read the note part. So he says we can overload the main method, but the JVM calls the main method that receives string array as arguments. Okay, this is a really good fact. Okay, even if you provide overload for the main method, JVM is still going to call the one with the array of string arguments. Okay, so here he has provided 2 more overrides than the usual main method. One is the one with the only string parameter, and the other one has no parameters at all. But again, JVM calls this override. Okay, so there are certain rules to follow for polymorphism. Okay, so at compile time you need to follow these rules in order to have compile time polymorphism. So compiler only knows reference type, that's why it's called compile time polymorphism. Okay, like binding happens at runtime, right? So like it doesn't know the exact object, it only knows the reference type, and it can only look in reference type for methods. Okay, and outputs a method signature. It will tell like this method will be called, this signature will be called. This is what is compile time polymorphism. Now let's move to runtime rules, okay, or runtime polymorphism. So at runtime, JVM follows exact runtime type, object type to find method. Okay, so this is a kind of late binding happening. Okay, so at runtime, it binds the object correctly depending upon the type used to create the object. So this must match compile time method signature to method in actual objects class. Okay, so this is runtime polymorphism. Okay, so method overriding is an example of runtime polymorphism or late binding. Okay, so let's read its definition. If a subclass has the same method as declared in the superclass, that is known as method overriding. Okay, so there are certain rules attached with method overriding. So these must have same parameters list, must have same return type as well, although covariant return allows us to change the return type of the overridden method. Okay, and must not have a more restrictive access modifier, may have a less restrictive access modifier. Okay, must not throw new or broader checked exceptions, may throw narrower checked exception, may throw any unchecked exception. Okay, only inherited methods may be overridden. Must have is a relationship. Okay, example of method overriding is this programmer. Okay, Java programmer extends programmer. This code, this is the override which he has provided. Okay, so here parent class reference child class object. Okay, so what object would be called, what method would be called when he's calling the code? The one which is present in the child class, that is going to be called. Okay, so the answer is coding in Java. Okay, so let's read this note statement now. So static methods can't be overridden because methods are overridden at runtime. Okay, so static methods are associated with classes while instance methods are associated with objects. So in Java, the main method also can't be overridden. Okay, so main method is static, so you can't provide an override. You can't provide an override to the static things. Okay, you can provide overloads. So constructor can be overloaded but not overridden. Okay, you can overload the constructor but you can't override them. Object type and reference type. Okay, so this is a person class and he has provided an implementation of eat. Then student is a person and he is provided an implementation of study. Then what he has done is he has created a class inheritance checker, and in main method he has used parent class reference and parent class object. Okay, which eat is going to be called parent eat is going to be called person is eating. Okay, and then he has created child reference and child object. Okay, then he is calling the eat on Jane. Okay, so yeah, so the name is different, right? Eat and study. So overriding is not happening. Marry, right? Okay, so the next topic which we'll be studying is object typecasting. So sometimes interviewers asks about knowledge of casting as well, like what is upcast, what is downcast, what is widening cast, what is narrowing cast. So these sorts of things you should also be handy when you are going in an interview. So Java typecasting is defined in two types. Okay, one is widening cast, implicit or like automatic type conversion, and the other one is narrowing cast or explicit. Okay, this needs explicit conversion. So in primitives, long is a larger type than int, right? Like in objects, parent class is larger type in child. So the reference variables only refers to an object. Casting reference variable doesn't change the object in the heap, but it labels the same object in another way by means of instance members accessibility. Okay, so widening casting is fine, but this is an example of narrowing casting. Okay, so we have to be careful when narrowing. When narrowing, we convince the compiler to compile without any error. If we convince it wrongly, we'll get a runtime error, right? Class cast exception. To perform a narrowing correctly, we use instance of operator. Okay, it checks for an is a relationship. Okay, so what is happening here is we have a class A and this has a display method. Class B is extending class A and we are overriding the display, and in test we are creating an object A, and we have parent class reference and child class object, and we are checking like whether object A is instance of object B. So object A is like, what is this going to return? This is going to return true, right? Object A is instance of object B. So we can do this kind of cast and the display would execute and we are going to see the override into action, which is class B. Okay, so this ensures that the override is fine. Okay, as I stated before, we must remember one important thing when creating an object using new keyword. The reference type should be the same type or a super type of the object type, right? This is the thing we need to keep in mind. Okay, this is what he is emphasizing here. Now he has concluded this. Okay, so I think we have covered all the OOPS principles from encapsulation to abstraction to inheritance to polymorphism. So if you have made it till here, thanks a lot for watching this video, and do give a thumbs up and leave your valuable comments in the comment section. Bye bye. Hey guys, do check out this Instagram channel, the Encoder Community, for all the jokes and memes related to software engineering. Thanks a lot.